questions. Here I am looking at question 6, and I'm going to be doing D as an example. Now, in question 6, they're asking you to complete this table. So you'll need to make a copy of it in your book. And then they want you to complete the given table. So what we're doing here is they're just getting you to understand and use interval notation. Unfortunately, the way the book approaches this, there's a small blurb of it back in page like 21 or something like that. But the book's basically taking that you already know how to do that. And interval notation isn't something that we do a lot of. So what I've done, I've copied the book, that image over here, so we can work with it. And this first one's A, B, C, D. So when I'm working through the problems, I'll be looking at that fourth one, which will be this guy right here. So first things first, a little bit on interval notation. And I found a little website that might help us out with this. So we're going to go through and explain interval notation, which you need for this question. Taking this from Cool Math Algebra at coolmath.com, which will be somewhat helpful. And what this is a method of notation. And just notation is just a name we have for how you write things. So this is just another way to write. Now, so far we've been working with x is greater than or equal to 0 or less than 4 to specify a domain. So this would be, if you were to draw it out on a number line, x could be 0, so we have a filled in circle, but it can also be every number up to 4, but not including 4, because we said x had to be less than 4. So this is a system, the notation we've been using so far, and this is what it would look like on a number line. So we want to know now, how do you show this in interval notation? So this website's using a very useful method where they've listed the closed option, the 0, as a red circle, and over here we have an open green circle shown here to represent the open part of the interval, the piece that's not included, right? We're not actually including 4. So the way we'd write this is like this here. So you have a square bracket, 0, 4, rounded bracket. Now when you see this, the square bracket means you're including that. So x or theta or whatever you're working with is greater than or equal to whatever number's here, because it's a square bracket, and it's less than and not equal to, only less than the number here. So we would say it's greater than or equal to 0 and less than 4. So this method of notation means the same thing as this, and you can see it takes a lot less space to write that, and it's a much better interval notation. So let's go on and look at one more example before we go on. So here you have x is greater than -7, less than 10. So this is going to look like rounded bracket, -7, 10, rounded bracket. So it's saying x is greater than -7, but less than 10. Right? Neither of these numbers are included, just all the numbers between them. But if we go look at a different situation, then x is greater than 3, less than or equal to 205. So you'd write it like this. X is greater than 3 and less than or equal to 205, because you have the square bracket here. So if you want, go to coolmath.com. Here's the link. Maybe I'll throw it in the blog as well. And it's got some you can go through and test your knowledge of interval notation. It's possible you've seen this in prior math classes, but it's one of these things that doesn't necessarily always get used too often in high school, so it's possible it's the first time you've seen it, and since we're going to be using it for this question, I want to make sure you have a clear understanding of it. So now that we understand how this works, we're going to go take a look, and on interval notation, we're saying that theta belongs to this range. So this piece of it just says that theta is somewhere in this range, somewhere between 0 and pi, and we just need to rewrite it in the other form. So here we see a square bracket, so that means 0 is included in this instance. So let's start with this. So let's say theta, and as we notice, there's a square bracket, so it's going to be theta is greater than or equal to the value that's there, so that's 0. But it's going to be less than, then let's check. So it's a rounded bracket, so it's just less than. We're not including this final number, so that's just pi. So it's theta is greater than or equal to 0, but it's less than pi, and that's what this is saying here. So maybe we do one more example just to make sure you guys are following along. We'll go take a look at this one. So again, theta belongs, we've seen this symbol elsewhere before, to negative pi and 4, and note what the brackets are. So we'll start by writing what our theta is, and we know we're going to have these symbols, so I'll just pop them in. And now let's look at the brackets we're using. So this one's a rounded bracket, so this is going to stay theta is greater than, whatever that is. And over here, this is a square bracket, so this will be theta is less than or equal to that value. So now I just write in the final values. So it's negative 2 pi, and then that one over there, we pop in, is going to be 4 pi. So this means theta is greater than negative 2 pi, but less than or equal to 4 pi. So that's how we're doing with that. So, yeah, so go through, take a look at these. The answers will be in the back, so you can check if you've done them right or not. And just remember, rounded bracket means less than or greater than, just depends on which side it's on. And if it's a square bracket, it's a greater than or equal to or less than or equal to symbol. So go through and try out those problems. If you have any questions, feel free to ask in class.